Let's do one more example. First, let's find the third Taylor polynomial of g of x is equal to cosine of x at the point a is equal to pi over 2. This should be pretty routine by now. In order to calculate the third Taylor polynomial, we first calculate the first three derivatives. Then we can plug in the center, which is pi over 2, and apply the general formula for the third Taylor polynomial to get that the third Taylor polynomial is equal to 0 plus negative 1 over 1 times x minus pi over 2 plus 0 over 2 factorial times x minus pi over 2 squared plus 1 over 3 factorial times x minus pi over 2 cubed. And we can simplify this to get negative x minus pi over 2 plus 1/6 times x minus pi over 2 cubed. Now, let's use the fact that the Taylor series is alternating to determine the max possible error in using this approximation to cosine of x on the interval pi over 4 to 3 pi over 4. Recall the alternating series estimation theorem, which says that the error in approximating an alternating series by the nth partial sum is less than or equal to the absolute value of the n plus first term in the series. Therefore, the error in approximating cosine of x by this third-degree Taylor polynomial is bounded above by the absolute value of the next non-zero term of the Taylor series. If you calculate the next few terms, you'll find that the next non-zero term is the fifth-degree term, which is negative 1 over 5 factorial times x minus pi over 2 to the fifth. Therefore, by the alternating series estimation theorem, the error in approximating cosine of x by its third-degree Taylor polynomial is less than or equal to the absolute value of minus 1 over 120 times x minus pi over 2 to the fifth, which is less than or equal to 1 over 120 times pi over 4 to the fifth, since the radius of our interval is pi over 4. And this number is about equal to 0.00121. Therefore, we have found that the error is bounded above by 0.00121 on the interval pi over 4 to 3 pi over 4.